Hello and welcome to yet another session of solving some algebra online via worksheet. We're going to start today with some radical equations and solving them. Uh, this worksheet is very straightforward actually, because all you need to think about with this is how do I reverse each of the processes involved? Because that's how you solve an equation in general, right? If you have x plus 6 equals something, you go, all right, I gotta do minus 6 to both sides. That is the inverse operation. If we were to say 7x equals, you go, oh, well, I gotta divide by 7 on both sides. Well, here we have square root of x equals something, and the way to reverse square root is to kind of do the opposite, if you will. We're going to do an inverse to that, and that means we're going to square both sides. And that is precisely what we will do right here with pretty much every single one of these questions. So we're going to say if we were to square both sides here, really I should write that squared on each of these to be more clear. So the square root of x squared, the square root and the square will cancel each other out. They'll negate each other, and we'll just end up with x. X equals 10 squared. What's 10 squared? X equals 100. Now check it. Put 100 in right here. Square root of 100 is 10. Okay, seems to work. So if we were to square both sides for number 2, we'll get 100 equals m over 10. Obviously, that's not fully solved. We now need to undo the divided by 10. So we will then say, okay, well, how about times 10 to both sides? And we'll get m equals 1,000 just by adding an extra 0 there. If we go to number 3, squaring both sides gets us v minus 4 equals 9. And then we will add 4 to both sides and get v equals 13. Now, it's worth noting before when we had squared type stuff, I was very adamant about needs to have plus or minus when you square root both sides. And that is true. However, when we are going in the other direction, that is not important because the square root operator by itself specifically refers to the positive version. That's why when we had this before, we had to write the plus or minus because it was either plus square root of 16 or minus square root of 16. Well, this, as written, is just the plus version, so we're not going to have to worry about that. All right, so we'll square both sides. 6 squared is 36. The junk under the square root squared is just the junk under the square root, and we will add 2 to both sides. Nice and simple. Square root of n equals 9, square both sides, n equals 81. 5 equals the square root of x plus 3, square both sides, 25 equals x plus 3, and then subtract 3 from both sides. So what happens when it gets slightly more complicated, like down here in number 9? Well, let's think about what's going on here. If we had to write out the steps of what is happening to A, first thing that happens to A, if we knew what A was, and instead of knowing what this number was on the right, we had to just say, let's solve it by plugging in some number. What we would do to A, number 1, we would multiply by 5, then we would subtract by 5, then we would square root, and then we would do negative 8 plus. All right, well, when we solve equations, we go backwards. We have to strip that away one level at a time. So the first thing we're going to do is take care of the negative 8. Well, let's remember that this is kind of like saying square root minus 8 if we just reordered that. So we're going to say, let's add 8 to both sides. And we will get square root of 5a minus 5 is equal to negative 3, yet another 5 in this question. Lots of 5s here. 5, 5, 5, 5, 5. Okay, so that takes care of that step. Now the next thing we have to strip away, the thing that is outermost to this equation, is the square root. So in order to undo the square root, we're going to square both sides. And so that's going to give us 5a minus 5 equals 25. And then from here, I hope you should be pretty familiar with this process because this is a pretty basic two-step equation. So we'll add 5 to both sides and get 5a equals 30. Ugh, horrible handwriting, but we'll deal with that. And then, of course, we're going to divide by 5, and we get a equals 6. If we were to, say, tackle number 12, it's going to be a similar idea. Think about the steps we need to reverse. What's on the outside? Is it the minus 10? Is it the times negative 10? Or is it the square root? The thing that is, I'll call it farthest away from the v, maybe not in terms of physical measurement distance, but I would argue that the minus 10 on the outside, the multiplying minus 10, is going to be the thing that we need to strip away. So we will divide by negative 10. And that gives us the square root of v minus 10 equals 6. Okay, and now we'll square both sides. The square root of stuff squared is just stuff. Oops, no, equals 10 minus 10 equals 36. And then we will add 10 to both sides, and v equals 46. So hopefully this should give you an idea of how to approach questions like this. Now, what if we were to scroll down and, oh my goodness, there's a whole nother page of more of this stuff. Are you surprised after my last videos? I'm sure not. So once again, we'll strip away the layers. 10, the plus 10's on the outside, so square root of 10m minus 1 equals 3. Square both sides, 10m minus 1 equals 9. Add 1 to both sides, 10m equals 10. And divide by 10, m equals 1. This would still be the same process even if some of these numbers weren't coming out nicely. It looks like all of these are rigged to come out nicely, but if you had something that didn't, you'd go through the same steps. So let's jump ahead just a little bit and look at now at 17 here. It kind of changes the game a little bit because it's square root equals square root. Does that change anything? I mean, if I said 5x equals like 10y, you'd still divide both sides by 5, wouldn't you? You'd still say, oh, well, both these things are times 5. Let's undo that. X equals 2y. And yeah, that's got two variables. You don't actually solve it, maybe, but the point is that we'll just apply that process to both sides and it'll help take care of things on both sides. And that's exactly what we're going to do here. We're going to square the square root of 3n to make it 3n. But if we square that side, we got to square the other side, and hey, this is also a square root. Square root squared cancels out, so to speak. So 3n equals 4n minus 1. Okay, doesn't seem like this is too bad to solve. We'll do a plus 1 on both sides. We'll do a minus 3n on both sides. And now we've got 1n equals 1. And there's your answer, n equals 1. Let's square both sides here. 2n minus 88 equals n over 6. All right, now this might be a little trickier to solve just because we got a fraction, and I know most people hate fractions. Why don't we make this a little easier for ourselves and say, let's just multiply everything by 6. I know that's going to make the numbers bigger, but at least we won't have to deal with icky fractions anymore. So 12n minus, we're distributing a 6 to this. So 6 times 88 is 480 plus 48. It's not 528, is it? 88 times 6, 8, 4. Wait, no, I'm sorry. I can, yeah, no, 4. And then we go 6 times 8 is 48, plus 4 is 2, 5, yeah, 528. Okay, I did it right with some errors in the middle. And then n over 6 times 6 is n, 1n. All right, we'll subtract n from both sides. We will add 528 to both sides, and you should end up here. Now, I'm pretty sure that doesn't divide in nicely, because uh, that just doesn't strike me as, well, maybe it does. Let's grab a calculator. So I'm going to pick up my calculator rather than try to do this one by hand. And oh, it does divide evenly. I stand corrected. It is n equals 48. Okay, slightly more complicated question, but not really a big deal when you get down to it. Of course, we didn't have to multiply by 6 if you didn't want to. Alternatively, we could have said, all right, 2n minus 88 equals n over 6. We could have said, let's do minus n over 6 to both sides and plus 88 to both sides. And said, all right, this 88 and 88 go away. The n over 6 and n over 6 go away. We've got an 88 over here. We've got 2n minus n over 6. Let's remember that if we made a common denominator, this would be 12n over 6. So we've basically got 11n over 6 equals 88, which is the same thing as 11/6 n. So to undo this, we will multiply by the reciprocal, which is the same thing as dividing by 11/6. And so n equals whatever that is. 88 divided by 11 is 8. 8 times 6 is 48. So actually, I was going to say grab a calculator, but I can do that one. So that would be an alternative path for solving number 18 if you don't want to clear the fraction. But generally, I think clearing the fraction is a slightly smoother way to go. All right. We'll do maybe 2 more of these. So number 19, we'll square both sides and we get x over 10 equals 3x minus 58. I'm going to multiply everything by 10 just to clear this over 10. So I guess I should grab a color and write that 10 times. That gives us x equals 30x minus 580, distributing the 10 to the right side. All right. Then we will subtract x from both sides, and we will add 580 to both sides. Sorry, number 21, you're not there anymore. And then we'll divide both sides by 29, and 580 divided by 29 is 20. All right, which one looks most interesting from here? Let's talk about 26. 26 seems like a slightly interesting question. So if I were to square both sides for number 26, I'm going to get x plus 8 equals 3x plus 8. All right, well, let's subtract 8 from both sides. We get x equals 3x. If we subtract an x from both sides, we get 0 equals 2x. And if I divide that by both sides by 2, I get x equals 0. Does that check out? Well, if we put a 0 here, we get square root of 8 equals square root of 8. So yeah, that seems to work just fine. So there is the process for solving some of these square root equations. Now, I do have one more sheet to look at way up at the top here. And oh, look, it is similar questions at first, isn't it? So we're going to look at number 1, and we're going to say, oh, well, first off, we got to strip away this plus 17. Square root of 3 minus 2v, subtracted 17 from both sides, we get a 3 over here. Square both sides, 3 minus 2v equals 9, because of course the square root is the outermost thing that's taking place here. Now the outermost thing is this 3 over here. If it helps, think of this as negative 2v plus 3. So we'll subtract 3 from both sides. Negative 2v equals 6. And then we'll divide both sides by negative 2, and v equals negative 3. All right, this seems complicated enough. Let's do a sanity check. Square root of 3 minus 2 times negative 3 plus 17. 2 times negative 3 is negative 6, so 3 minus negative 6 plus 17. 3 minus negative 6 is 9. Square root of 9 plus 17. So that's 3 plus 17. And that is indeed equal to 20, which is the other side. So we're good. Yep. All right. Number 2. Outermost thing right here is the plus 15. So square root of 4k minus 11. We're going to subtract 15 from both sides and we get negative 13. Okay. Now, I want you to take a time out and remember what I said earlier when we talk about the square root operator. I realized that when we had like x squared equals a number, we said x equals plus or minus the square root of 6, right? Is there a plus or minus here? And so what has to come out of here? What kind of number? Will there ever be a negative? Yes or no? There shouldn't be a negative resulting from a regular old square root. This is always a positive number, and we're being told it's equal to negative 13. So positive equals negative? Can that happen? Nope. Answer to this one is no solution, or at least no real solution. You could argue there is an imaginary solution. If you really want to see that, we'll go through it real quick here. 4k minus 11 equals 169. Actually, I don't think this is going to get us there because we don't have an I going on. 4k equals 180, k equals 45. That's not going to work out for us though, because if we put a 45 here, 45 times 4 is 180, minus 11 is 169, square root of which is 13. We would get 13 plus 15, which is not equal to 2. So that is very much an extraneous solution. What we would have needed is for the square root to be a negative 13, right? If we have negative square root of 169 plus 15, that would give us a 2. There's no way to generate that, so even though I said something about imaginaries a second ago, that's actually false. We cannot get this at all. All right, so let's try number 3. We're going to have a negative 7 on the outside of our radical. So that seems to me like that is the outermost thing that is taking place. Let's divide by negative 7. We're going to get 4th root of m plus 1 equals negative 2. Now, once again, a 4th root is like a square root because when you raise something to an even power, whether it's to the 2nd or to the 4th or the 6th, it's always going to become positive. If we had like negative 3 to the 4th, it's negative 3 times negative 3 times negative 3 times negative 3. That's 4 negative signs. So you go negative, positive, negative, positive. That's a positive answer. So will we ever get something that the 4th root of it is a negative? Same argument here as before. If we were to do like to the 4th power, which would be what we would do to undo this, we'd get m plus 1 equals negative 2 to the 4th is 2, 4, 8, 16 with 4 negative signs, which makes it positive. We'll subtract 1 from both sides, we get m equals 15. But coming into here to the original, 15 plus 1 is 16, negative 7, 4th root of 16 is negative 7 times 2, which is negative 14, which is exactly opposite what we need. So as you should have been able to guess from seeing even root equals a negative number, the answer to this one is, again, no solution. Now, I will say as a caution, that would not be true if this was a cube root. Odd roots you can raise and get a negative because if you cube a negative, you do get a negative. So it is possible to then say, well, if I cube root this, it'd be like cube rooting that. And so the cube root of negative 27 is negative 3, and that is a-okay. And in fact, it is also true that we could say negative 3 equals the cube root of 27 with a negative on the outside as well. So that'll work with odd roots, but it will not work with even. So we'll keep that in mind when we look at number 5 and number 8, because those have cube roots in them. But let's carry on with where we were at. So number 4, the x is on the right side, so we will get this negative 11 away from the right side. X plus 7 to the 1/2 is equal to, add 11 to both sides, we get 6. All right, so this is different, or is it? What does it mean to be to the 1/2 power? Well, if we use our exponent properties, we should say, well, let's just take this to the second power and this to the second power. And when we do 1/2 squared, that's power to a power. We multiply the powers and we get x plus 7 to the first equals 6 squared is 36. And to the first power is, of course, just the quantity itself. So now we'll subtract 7 from both sides and get x equals 29. Now, before we were squaring both sides because we had a square root. Now we're squaring both sides because we have a 1/2 power. Oh, that's right. That's because x to the 1/2 is the same thing as square root of x. Silly me, I forgot. Tee-hee. Okay, so this really shouldn't surprise us. And likewise then, when we see number 5, we should remember that 1/3 power is the same thing as a cube root. So we're going to add 7 to both sides to get rid of this negative 7. So 16p plus 8 to the 1/3 is equal to 6. And then we will say raise to the 3rd power to get rid of the exponent we've got. And we get 16p plus 8 is equal to 216. All right, subtract 8 from both sides. 16p equals 208. I don't want to try to do that one in my head, even though I could probably figure it out. Calculator tells me that this is p. Oops, don't want to bleed into the next one so I can see the text. P equals 13. All right, how about number 6? Number 6, we've got, take away the 17. It's on the outside. Of course, if you're confused about this, once again, I'll remind you that you could rewrite this like this. So if that helps, write it like that so that you can realize that the plus 17 is easily subtracted. So negative 2 square root of 3x plus 10 equals negative 16. And at first we're a little scared because we got a square root equals a negative, but it's okay because we also got this negative out here. Divide by negative 2, and now we've got square root of 3x plus 10 equals a positive 8. All right, that checks out. We can do this. So we'll square both sides, and we'll get 3x plus 10 equals 64. Lots of steps in this one. We'll subtract 10 from both sides. 3x equals 54. And finally divide by 3, and x equals 18. All right, there was a lot going on. I think we better check that one. You probably should check all of these, but we should definitely check this one. So let's suppose that we were to plug in here and we said 17 minus 2 square root of 3 times 18 plus 10. Does it equal 1? I'll put an equals question mark here. All right, and to make this more clear, we'll turn the square root thing into a bracket. All right, is that too small? Maybe that's a little too small. Let's go to the next font size up. How about this size? Yeah, that looks a little better. Just didn't feel like handwriting every single one of those. All right, so 17 minus 2 square root of 3 times 18 is 54 plus 10. Does it equal 1? 17 minus 2 square root of 54 plus 10 is 64. 17 minus 2 square root of 64 is 8. 17 minus 16, does it equal 1? And sure looks like it to me. Yes, okay, works, checks out, everything's good. All right, these last two questions, so they're going to be like we had at the bottom of the last sheet, where we've got a square root on both sides, so we will cancel the square root on one side by squaring, and it will cancel the square root on the other side. So 3k minus 29 equals 41 minus 2k. Now I will say we are going to want to check these for extraneous solutions, because it could have been that we had some sort of weird positive number squared type equals negative numbers squared. I don't think that's going to happen because we've got square roots on both sides, but I'm still going to say let's check it. So we're going to add 2k to both sides, bring our k's to the left side. And while we're doing that, we will bring the loose numbers to the right side. If you want to do that in 2 steps rather than 1, you're welcome to do so. 5k equals 70. Divide both sides by 5, and we get k equals 14. All right, check it. 3 times 14 is 42, minus 29, that's the square root of 13. 2 times 14 is 28. 41 minus 28 is the square root of 13. So, yup. All right. And finally, number 8. Let's deal with a cube root. 1/3 power means we gotta cube both sides. We're gonna cube everything. All right. Doesn't really change the question. We're still just stripping away the 1/3 here. 3x minus 21 equals 19 minus x. All right. So we'll add x to both sides, bring the x's to the left. And while we're doing that, we'll bring the loose numbers to the right. And we get 4x equals 19 plus 21 is 40. Divide both sides by 4, x equals 10. All right, so that solves all of that. Now, I'm going to hit clear here, and I'm going to suggest we talk about one other style of question just in case it comes up. I don't see them on this worksheet, but I do want to ask one other style. So I'm going to make up a question here. I'm going to say, what if we have the square root of x plus the square root of x plus 12 is equal to 6? This is a much, much more sophisticated question, and I'm going to bet good money if you're seeing questions like this over here, that the next thing your teacher's going to do is ask you a question like this. So let's talk about how we deal with something like this. It would be great if we could just square both sides, but the problem is if we try to square both sides here, we're technically doing FOIL, right? We have to do first, outer, inner, last, because we've got, you know, this and that and this and that, and that's bad news. We don't want to deal with that. So that is not how we approach this. What we are going to do first is we are going to isolate one of these square roots. So I'm going to say, let's subtract this square root from both sides. We could have subtracted the other one. That's perfectly fine as well. This way is going to be a little simpler for reasons that hopefully will become obvious in a second. So we're going to say square root of x equals 6 minus the square root of x plus 12. Now, we still have to square both sides, and that still means we're going to have to do FOIL. But it's actually a little bit nicer this time. So the left side of this is just x, right? X equals, but we got to do 6 minus square root of x plus 12 times 6 minus the square root of x plus 12. If you know your binomial square, you can do this a lot faster than the way I'm writing it out. So x equals first, outer, inner, and last, minus quantity x plus 12. All right, now that doesn't look nice. Does not look nice at all, but let's dress it up. We got 36 minus a 12, right? This 12 over here is being subtracted, so that's 24. We've got a minus x here. And these two terms are like terms, so we're going to put them together. Minus 12 square root of x plus 12. And yes, it was gross to begin with. It's still kind of gross, but what we're going to do is exactly what we did before. We're going to isolate this square root. So it means we're going to add x to both sides, and we're going to subtract 24 from both sides. And we're going to say negative 12 square root of x plus 12 equals, over here we've got 2x, uh, and then we've got a minus 24. Hmm, okay. So we'll add, or I'm sorry, we'll divide both sides by 12. I'm starting to run out of decent colors here. And we'll say that 2x over 12, negative 1/6 x plus 2 is equal to the square root of x plus 12. Actually, you know what? You know what? I'm not going to fully divide by 12 because that's going to give us icky fractions. I could do this. I could do that, but I think I'm going to back this up because I know what my next step is. I'm going to say let's not. Let's just not do that. How about instead we just divide by negative 2? That way we don't end up with fractions. I do want to get rid of this negative. Negatives are bad news sometimes, but I'm just going to divide by negative 2 instead. So negative x plus 12, or 12 minus x if you prefer, equals the square root of x plus 12, but we didn't fully divide. We still got a 6 out here. All right, so once again, we can actually square this now. We can go squared. We're going to need to be cautious about how we do that, but we can now square this side. All right, so the left side, this is a FOIL situation. We've got 12 minus x times 12 minus x. And yes, you're noticing that this is a much, much more tedious question. And this, we need to square both things on the inside. So it's 6 squared times the square root of x plus 12 squared. So we've got 36 times x plus 12. My goodness, this is going on way longer than I expected. I hope I didn't make a mistake somewhere because this is more complicated than I expected it to be. If you do the FOIL over here, you should end up with something like this. All right, so let's take this up and over to the other side here. So x squared minus 24x plus 144, that's just rewriting in descending order. And on the right, we've got equals 36x, because I'm distributing, and 36 times 12 is 432. And we've got ourselves a quadratic equation. So I'm going to subtract 36 from both sides. Sorry, 6x rather, and I'm going to subtract 432, which is minus 288, equals 0. All right, solving that, we could do quadratic formula, or we could look for factors of 288. I say I'm going to factor this, but if you want to hop right into the quadratic formula, you're welcome to. So negative 288, we know we've got 1 times 288, 2 times 144. Not a, do we have a 3? We have a 3, right? 288 divided by 3 is 96. We need things that are much closer together, so I should probably skip ahead a bunch, but I'm going to be thorough. 288, there's lots of factors of this number, by the way. 6 times 48. 288 divided by 8 is 36. This is looking awkward here, because I need something where we subtract 1 and add the other and we get 60. I really feel like I made a mistake somewhere. I feel like this didn't go correct. Let me make sure that I picked a number that works here. I put that there and I put that there. Yeah, this is supposed to be x equals 4 because it's going to be 2 plus square root of 16 is 4 equals 6. So let me review my work here and make sure that I didn't mess up. So square root squared 6, that looks right. X equals 36 minus 6, 6, minus x. This is minus x minus 12. So 36 minus 12 is 24. We got a minus x, and we put these together, sure. We add 24 to both sides. We add x to both sides. 2x minus 24 equals negative 12. Bleh. I tried to make this a little nicer on us by making the numbers not quite as stratospheric. Square both sides. That looks okay. 36x plus 12 times 36. I did on the calculator, right? That is 432. 144 minus 432 is negative 288. Negative 24 minus 36x is negative 60. Yeah, all right. Well, let me see what happens if I put this into the quadratic formula. Maybe I missed a factor pair. 1, negative 16, negative 288. I have a calculator program that does this for me. I wrote myself. And those aren't coming out nice. Okay. So I must have screwed this up because the answer we were supposed to get was square root of 4 plus the square root of 4 plus 12 equals 6. This is how it was supposed to work out. This is 2, square root of 16 is 4, and that ends up being, whoops, equal to 6. All right, so I guess we need to ignore this back half of the discussion, but the idea behind what I did still holds true. So the process should have worked. I'm not really sure what went wrong here. Um, I'm not seeing my error. If I stare at it for another 10 minutes, maybe I'll figure it out, but I'm not going to re-record this whole video just to edit this part out. So if you do see a question like this, okay, it's going to be something like this with a whole lot of steps. You have to square both sides, bring everything else to one side, then square both sides to get rid of the other square root, and then solve a quadratic. And hopefully the quadratic shouldn't be a big deal. Usually when you do this, you end up with x squared equals x squared, and the squareds drop out. So I feel like there's supposed to be a squared over here, but it doesn't look like that worked out that way, huh? All right, I don't know. Anyway, I'm going to leave it at that. Let's pretend we never saw this flush. It was never there. You saw nothing. And I'm going to say that what we did for our worksheets, though, that is absolutely a-okay. And I hope that at least that part was helpful and that I didn't lead you too far astray with the last bit. Thanks.